So let's rewind in your memory here a little bit to the days when you first started working on E5-2600. What was going through your mind?
We really wanted this microprocessor to be a bandwidth machine. We recognized that prior generations tended to be bandwidth constrained. And what I mean by that is, as you add more cores to the microprocessor, you have more data that you need to get in and out of the CPU as quickly as you possibly can. So we architected it to address these requirements. We have up to 8 cores. Each of those cores is multi-threaded. So we have effectively up to 16 cores which need to get data in and out of it as quickly as possible. So how do you go about addressing that? A CPU gets bandwidth from multiple manners. One is the last level cache. Cache is basically memory that we bring closer to the cores. And by bringing it closer on die, you can get data in and out as quickly as possible with very low latency as well as high bandwidth. And what we did was with the interconnect, we connected all of these cores together in a ring topology, basically allowing all the cores to access data simultaneously, giving a tremendous amount of bandwidth. So the last level cache logically is one cache, but physically it's been broken up into multiple slices, all which can be accessed simultaneously. The second attribute of bandwidth is memory bandwidth itself. We went to 4 channels of DDR on this particular microprocessor, giving us 33% bump up in bandwidth. The other way to get more bandwidth is for accesses to what we call remote memory. So CPU itself has a number of cores, and it has a certain number of DDR channels connected to it that it gets data from. But a great deal of its memory also may be on another socket, on another CPU. And so to access any data sitting on another CPU, we have to go over QPI. And QPI is our coherent links that we use to interconnect all the CPUs together. And we have up to 2 QPI links in order to connect multiple CPUs into a variety of topologies. And that's how we provide the bandwidth.
Does moving the PCI interconnect onto the processor, was that another piece of the bandwidth puzzle?
Prior art, all the PCI Express connectivity was done through what we called an I/O hub. The I/O hub was another component in the platform which bridged between QPI, the coherent links, and which would connect to the microprocessors, and the PCI Express. One of the big innovations that we did with this CPU is by taking PCI Express and implementing it natively right on the microprocessor die. By doing that, we provide a great amount of scalability for I/O that we haven't had before, which is very nice because now as you add CPUs and as you add cores, you add, of course, memory channels, but now you also add I/O with it. So it scales nicely. As you add CPUs, you add DRAM bandwidth, and now you also add I/O bandwidth.